So, Assalamualaikum warahmatullahi wabarakatuh. Hello, Mrs. Olfine, everyone. We're from Group 5. Today, we are proud to present our final project titled Sentiment and Public Opinion Analysis on the new Minister of Finance PURBAYA di SADEWA on the YouTube platform using INDOBERT, DBSCAN, Key-Means Clustering, and Profit. So, this is our team, Abdullah, Al-Firdaus, Nuzula, Halilatunnisa, and Elvira, Tiara, Suci, Tambunan. So the background is actually recently with the appointment of Purbayu as the new Minister of Finance, there has been a significant increase in public discussion on YouTube. So we have three main objectives of this project. First is determine public opinion is neutral, negative, positive, categorize public opinion, and to predict future comment with profit. And this is the scope and limitation.
First, the scope. Jadi, this project analyzes public opinion using YouTube comments, and then the study applies three main method, which is INDOBERT, Key-Mean Clustering, and Profit. And then for the limitation, the analysis is limited on YouTube data, so it doesn't represent opinion from the other platforms. And then in the addition, the sentiment analysis result may be affected by informal languages. Next. So there are the future lists of our data set, which is video ID, comment ID, alter, publish ad, update ad, test display, like count, and also replay count. Next. So the result of using INDOBERT, this study applies to experimental scenarios, which is the first is using the 100 data set are manually labeled. So the data is tokenized using INDOBERT and used for initial fine tuning. And the trained model then predicts the remain data and calculate confidence score. So the high confidence data is selected as pursuit labels combined with the labeled data, and INDOBERT is fine tuned again to detect unlabeled data set. So the second is using the first 1000 data set are manually labeled and balancing, so the data in each class has an equal number of sample. Then the balanced data is tokenized and used to fine-tune INDOBERT. Pursuit labeling is then applied by selecting high confidence prediction, combining them with the labeled data, and refine-tuning the model to detect unlabeled data set. Next. For the best on the performance comparison, the model trained with 1000 balanced labeled data achieved significantly higher accuracy and better stability compared to the model trained with only 100 data points, and accuracy of 0.93, and consistent performance across all classes indicate that this model produces more reliable and representative sentiment levels. Therefore, for the next analysis stage using Profit, this study adopts the classification result from 1000 balanced data model to answer higher quality sentiment input. Next. So the comparison show that both of the amount of labeled data and the balancing process significantly affect dataset quality before training. Using labeled data without balancing makes classes domination and increases bias. So in contrast, increasing the labeled data and applying class balancing produce a more even distribution and richer example for each class. Next. So for the analyzing of true present charts show that both of the amount of labeled data and the balancing method strongly influence data distribution quality, with limited labeled data and no balancing on class tends to dominate increasing bias. In contrast, expanding the data set through 1000 labeled sample and applying classes balancing result in a more even and less biased distribution. Next. So the variation observed in the two graphs indicate that both the amount of labeled data and the balancing technique have a strong impact on INDOBERT sentiment accuracy. When the labeled data is limited, the model tends to produce bias and unstable prediction due to a lack of representative samples. So in contrast, increasing the number of labeled data and applying class balancing allow the model to learn sentiment patterns more effectively. This emphasizes the importance of proper data preparation as sufficient and balanced labeled data leads to more accurate prediction and more reliable sentiment trends. Next.
Next, result of public opinion using K-means, overview of experimental approaches. YouTube comments were collected, cleaning, and represent using the TF-IDF. The optimal number of cluster was determined using the elbow method and silhouette score. And for the result, we interpret to the dominant words and word clouds, and also we compare to the back of words and the DBSCAN clustering. The TF-IDF and K-means combination proved more effective for high-dimensional text data. Next. Performance comparison, DBSCAN performance variance greatly with the epsilon parameter at the epsilon 2. Most data is labeled as a noise due to the large distance in high-dimensional text space, while at epsilon 20, unrelated data is grouped together, creating overlapping clustering. This shows that the DBSCAN is highly sensitive to epsilon and less effective for stable public opinion clustering on YouTube comments. Next. And the cluster distribution analysis. The first is TF-IDF with the K-mean show at optimal configuration at 5 and support by the elbow method and silhouette score, resulting in balanced cluster. In contrast, with the cluster distribution back of words with the DBSCAN produced highly unbalanced distribution with the most data classified as a noise, especially at the lower epsilon is in epsilon 2 values. The confirms that TF-IDF and K-mean provide more clearly and more stable clustering for public opinion analysis. Next. And this is the cluster percentage analysis, show a clear difference between methods. TF-IDF with K-mean cluster is dominated by the one major cluster at 90.9%, indicating a strong prevailing public opinion, while the smaller cluster represent less frequent views. In the contrast, back of words with the DBSCAN clustering classifies more data as a noise, 95.3 at the epsilon 2 and the epsilon 20. This confirms that TF-IDF with the K-means better captures the main public opinion patterns that the DBSCAN on the data text. Next. Cluster trend analysis over time by the K-means. K-means use a fixed number of the 5 category with the non-noise category, assigning all data points to cluster. Cluster first is dominate major peaks, indicating periods of highly comment activity and strong public sentiment. Next. And for the DBSCAN with the epsilon 20 dominated by the cluster during peak comment activity, with the smaller cluster remain low and stable, indicating overlay losing and then density criteria. And for the epsilon 2, the DBSCAN forms more clustering and captures with defined patterns. Although noise is show the high peaks to the outliers, small cluster becomes more distinct and stable. Next. And this is the word cloud. In our K-means, there are cluster 0 until cluster 4. Next.
Okay, this is the forecasting step. After we're labeling the comment -1, 0, and +1 for positive comment, we have average accuracy 82.33%. And then this is the visualization, historical trend overview from July until November 2025. The blue line is predicted value, and the light blue area is confidence interval. And then this is for weekly a trend. We found that Friday is the highest point of the sentiment trends and drop the rest of the week of weekend. and this is the forecasting for 2 weeks in the future. So actually, this is quite positive comment after 30 days. And yeah, that's for profit. We
And this
move
is the
to conclusion.
conclusion. In our project, using INDOBERT, public sentiment is dominated by neutral to positive opinions with the low negative sentiment and model achievement with the high accuracy 93.93, and for the K-means clustering, 5K discussion time were identified and compared to the DBSCAN FIDF with K-means is more stable and interruptible cluster, and for the Prophet model shows stable and positive sentiment forecast with average accuracy 980.33, performing best at 5-day horizon. Next. And this is for the suggestion. The first is expand data sources and real-time capability. And the second is enhance text processing and model robustness. And the last is improve forecasting with the external factors. That's all from us. Thank you.
Thank you.